As you can clearly see in the real-time live image, we currently have two distinct devices actively communicating and exchanging information with each other. This involves either the associated financial costs incurred or the actual data capture process itself. Data packets across the network are executed within the current data, or the data you are currently in, like your current home. Alright, this network has some devices, and these devices have their own functions. So you can perform this on the devices that are with you inside this network. Alright, that's really great. As you can see here, he's sitting in the middle between the two and listening to what they're saying. For example, this person says to him, "Peace be upon you." Alright? Or he's sending him data. So the attacker takes a copy of the data that's being sent to him, and in the same way, he replies to him. So the hacker is also listening to the conversation or the data being transferred between the two devices. These two. Alright? Inside, right? And now we're going to learn how we can actually do something like this in practice. Alright? That's great. So now we understand what this attack is all about, right? Alright? Alright. Let's move on to the practical part. If we open what we have here, which is, alright, and we have, alright, and its IP is 192.168.1.13. Alright, very nice. We're going to open a specific tool that is called, it's basically what we want to run. You'll just type it and hit enter, and you'll find it there. It worked for you. As you can see, it's basically a packet sniffer. It basically performs an attack, or sniffing, or intercepting the data packets passing through, right? Alright, it's a very simple graphical interface. You just select your network card. How do we know which one? As you can see, there is more than one network card. But if you look here, and if this is your main network, come to the first network card, which is ENS33, you'll find that it has pulled the address, which is the IPv4 and IPv6. If we want to make sure, if we open a new terminal, and if you type ifconfig, you'll find that your network card is called ENS33 and its IP is 1.15. That's great. So you select your network card and click on it. And it'll immediately commence the crucial process of capturing all the various data packets that are actively passing through the intricate pathways of the network infrastructure. As you can clearly observe, upon successful capture, you'll readily discover the precise timestamp indicating when each individual data packet was meticulously captured, along with their sequential identification numbers, ranging comprehensively from the initial packet, number 1, all the way through to packet number 21, or potentially even 22, depending on the specific capture session and its duration. And we have something called the source and the destination. The source is the sending device. And this is the receiving or listening device. Alright? The protocol is the type of protocol, the length is the size, and the info is about the connection. Alright? Alright? Just like you see here. Yeah, we're going to do a very simple example. Okay. As you know, there's something called ping. We're going to try ping now, alright? Alright. First thing, open up your original Windows. Alright. Great. And we'll set this up like this. Alright. As you can see, this is the original Windows interface. Alright. Which is mine. Alright. We'll do it on. Alright. Alright. And we'll try it. Will the one that's there be able to see the communication between these two or not? That's really great. We'll talk. On the machine, that's 192.168.1.13. And we'll tell it now it's happening normally. Alright? That's really great. Let's take a look so we can break this down. The type of protocol used by the bank is, so you'll find it up there. It tells you, alright? You'll tell it the protocol type, just like that, the protocol for the bank, which is, and then you hit enter. You'll find that some packets have appeared for you. Let's see how the communication happened. First, number 1 is the time, and the source is 192.168.1.5. Whose IP is that? Let's check. It's the Windows machine. If you type ipconfig, you'll see down here 192.168.1.5. That's my Windows machine. All right? If we look at the 192, which is 13, which is, all right, that's the one communicating. My machine is talking to the server, saying, peace be upon you. Basically, it's sending an ICMP echo request, all right? This protocol is specifically for a certain type of communication. So, as Mohammed, I check to see if the device in front of me is up or running or, working, right? All right. If it's working, it replies. If you look at the next connection right below, basically it sent or received a packet. The three of them aren't really in the right order, So my device, basically, talked to the other device and said, peace be upon you, or sent an ICMP echo request. So the connection for 192.168.100.13 should be here, all right? But since they're not in order, that's just what's showing up. So we removed that filter like this. Okay? And after we hit enter, let's take a look here. Let's scroll up a bit. Actually, let's scroll up more than we need to. Let's go down. Up, so we can clearly see everything. Or we can turn off the filter. Or turn it off and on again, so the packets are sorted. So we can read and do the ping. As you can see, the ping is happening right here. All right. Let's stop. All right, as you can see, just ignore my router, it's doing a broadcast. Ignore this packet. Right now, we're focusing on my device, which is the Windows machine, communicating using, it's saying, all right? Okay. So the device, or the one with the IP address 1.13, is replying to me using, also saying, or it's saying, peace be upon you, and God's mercy and blessings. All right? Then the process repeats. All right? My device is saying it's sending, and the server is replying to me, and so on. This process, as you can see, keeps going. Here, there were about 4 communications. As you can see here in the back. If you look here, you'll find there are 4. Here's 1, here's 2, here's 3, and here's 4. All right? Okay. You might say these are 8, not 4. I'll tell you, that's because the device is sending and receiving. So that's how it works, basically. Right? Okay. So now we've got a general idea about how things work, or what's happening, or how we can get information from. The connection between devices. Why? So, as a pen tester or as an attacker, what can I actually gain from this? What can I benefit from something like this? I'll tell you. Right? There's nothing much here, so there's no problem. For example, just as an example, we're going to use this in our work or in our setup anyway. So we'll try it on a user, okay? Will it be able to get information from these or not? All right? Okay. We're going to meticulously run this entire process and execute it precisely using our specialized and highly efficient tool. We will then instruct it specifically for FTP to diligently work on this particular task, ensuring a thorough and complete operation. All right? Of course. The specific username or its actual name. And the password is also anonymous. It tells me login successfully. If we type a question mark like this, we'll find these are the commands you can execute using the FTP protocol. Great, so let's see. Does Wireshark have the ability to capture the communication that just happened if we type in the filter? Let's take a look. Yes, it was actually able to capture or pick up those requests. All right, the first thing that happened, of course, they're not in order as you can see. As you can see, the first packet is 192.168.1.13. But that's not a problem. Right now, we just want to see whether it was able to capture the username and password or not. As you can see here. Here, this is basically the first thing that happened. All right? If you look at this message here, you'll find in the section called, if you select this and right-click, then scroll down to, if you examine the TCP stream, you'll clearly see that it prominently displays the specific username, a name called Waybath, or an abbreviation for password as well. And then it tells you, if it tells you, all right. So now we've managed to do it. I'm talking as an example, all right? I'm not dealing with it, first of all, the server, which is this one. All right? It's available on, all right? All right? You could do it yourself if you have it, just in case you're not sure about something like this. Yeah, install it on an external device and carry out this attack. But the communication has to happen between devices inside, all right? All right, as you can see, we were able to get the username and password very easily. All right, let's do it. All right, from this part. All right, very nice. Okay, let's try something else. We also want, for example, if I, Mohammed, logged into a website using a protocol and entered or signed in with the username and password. Will it be able to get me those username and password or not? No. All right, let's try. All right, let's stop. We're going to open the browser using the original Windows. We are now going to proceed with logging into the Windows operating system. The specific IP address we'll be using for this connection is 192.168.1.13. Once we have successfully logged into the Windows environment and are securely inside the system, we will then open up the Windows Explorer application. This will allow us to gain full access to all the necessary files and retrieve the data that we require from the system. All right, that's very good. As you can see, this happened, or those who understand or have studied this will get what I'm saying. Right? Alright, so let's also proceed to log into the system, specifically to Win, utilizing the designated username and the corresponding password. Once successfully authenticated, we will then carefully navigate and proceed directly into this particular section or area of the application. If we take a look, we'll of course apply a filter to this, and we'll tell it, let's do this. Press enter, and you'll see there are more. Of course, we don't need this right now, so let's maximize the screen like this. Alright, and let's enlarge this so it's clear. For us, it's the one that's mine, and then there's the one that's ours. First thing, the info about this request. I made the request, but it's not sorted. I requested the one that's... yeah? Alright. The response says, yeah, 302, or the code. The code. This is a code, or through it, I understand that there was some confusion. Not a problem, though. The 1.5 requested DVWA/login, so that's 13. He told me 200, okay, responded and said, your request is correct. The 1.5, my Windows, talked to the server and told it, I want the login file, right? So the server responded, and they told me it was 304, which is, okay, so I'm just explaining the significant difference between these two things, because in the end, we will clearly see what exactly I am writing and what it truly represents. All right? Or this message, it's exactly that. I'm just opening, right? All of this, okay? Okay. I'm sending, and the server's responding to it. All right. Or the server responded. Okay, now here's the important part. Or I sent a request of type post. or its method is post to the server. All right? Okay. When you see this, it means I entered data, meaning I wrote data and sent it. All right? Okay. We're going to go and select this, and you'll find a huge collection like this. All right? Of course, we can't make the text bigger. You have it down here like this. And instead of searching for the recipe and the source in this section, we can filter this topic. You'll tell it from below, find, and you'll be searching for username. Of course, the username field, of course, okay, and then we proceed to press the enter key. The username is displayed down below again. Yes, that's correct. Let's go back a step. Again, sorry. You'll tell it, and it'll bring you several things. Here, it'll show you first that the username will always be in red. The username is admin, as you can see, and the password is password. All right? So now we've managed to get the username and password. Fine? So now we've understood what the sniffing part is all about, right? All right? I mean, yeah, it's a huge topic. I mean, not a lecture, not even two, not even a whole course would be enough, all right? If you want to learn more, I mean, yeah, either way. The company has designed a certificate. You take the course with them, apply for the exam, and get their certificate, all right? I mean, can you imagine? You're getting certified in just one tool, like Wireshark, just that one tool. That means it's really huge, very deep, and extremely powerful, right? And if you want to know more, you'll find if you search. You'll find their website right there, but only if you're interested. Get to know their stuff. Just type. Or we can type, just so you know. Black. You'll go to their simple website and you'll find more than one thing there. Here you go, right now, or this will show you. Show only SMTP on port 25 and ICMP traffic, and so on. You can read more. If you want, you can check the description or search for a specific filter from here, and you can dive deeper into a tool like this. Alright, so now we've finished the scan find section.